In this video, we're going to be going over Building Java Programs Edition 4, Chapter 7, which is about arrays, and we're looking at the self-check problem number 10 through the free website Practice It that's accompanies the book. So in this problem here, we are trying to find the maximum value of this array here. And you should hopefully remember from Chapter 4.2, conditional execution, we learned about min-max algorithms, okay? But let's go ahead and start working on this method. So we know that we're going to have a method max. Okay, so public static. I'm going to just mark this return here for a second. Called max, and it accepts an array of integers. Okay, so I've got some videos that I've described previously, starting with 7.4, where I talk about how to use what's the syntax of an array. So we declare the type, and then we need to use the square brackets before we give the name, and we'll call this nums. Okay, and so this tells us that it's not just an integer nums, but it's actually an array of nums. Okay, and it returns the maximum value in the array, so that means that the return is going to be integer. And I'll go ahead and start putting some pseudocode in here. We know that we need to return the max value, right? Okay. And we know that this is a section 4.2 min-max algorithm. And that algorithm looked roughly as you need to initialize the, in this case, the maximum value. And then you have a loop. And inside the loop, you're going to test if current greater than the max, then replace the max. Okay, that's really the basic min-max algorithm. We just have to figure out how to do it now with an array. Okay, so first, let's go ahead and create that maximum value. And normally we would initialize that max value as like 0, okay? But in this case, we we're going to initialize it really with the first element that we have available. Even if that first element turns out to be a terrible value, maybe it's the lowest value in the entire set, or if it's the highest value in the entire set, it doesn't matter, okay? We just need to grab a value that we know is valid. Okay, it's one of these values. And then as we go and we look through each value, then we can see if that value is greater, we'll replace it. So we need to get the first element. And if you have been following along with my problems in this chapter, we know that in order to get the value out of an array, we just use the square brackets, and then we put the index in here. And the index is always start at 0. So that's where we're going to do the get that. Now, as far as the loop, we can definitely do a regular loop. Let's do an int index is equal to 0 while the index is less than. Now, how do we know how many elements are in this array? If you've been following along with maybe like 7. I can't remember which was the last problem I did, but we've learned previously that if you do nums.length, not a method like that, but just as a variable, then that'll give you the length, and then we can increment the index. And, oh, we already know that we can return the max value here, right? So that helps. Now, we have to test if the current value, so what's the current value? So the current value is going to be num. Again, we just have to fill in what the index is. So in this case, because I've intelligently named my variables, it's simply index. That makes sense. If num index is greater than max value, then what do we have to do? How do we replace the max? So we go max value equals num index. Okay, so that's going to loop over all elements, test if the current is greater than the max. If so, replace the max, and then we're going to return that max. So let's see if that works. Okay, we just need to do nums instead of num. All right, so that worked. Now I want to show you another feature that's introduced in this chapter. See how wordy this is? This works fine. It's plenty fine, but it's pretty wordy here, and this very common thing that we have to do is we have to loop through all the elements from 0 to length, and we are going to get the value at each of those elements. Wouldn't it be nice if there was a shorthand for that? Well, there is. Okay, so it's called the for each loop. So I'll comment that. We're going to use the for each loop. And what we do here is we're going to replace this with an int value equals, or sorry, for each int value in nums. Okay, what this does, it's actually shorthand. Java actually translates this in the background to the exact loop that I wrote there, except that instead of having the int index, it's got int value, and it assigns value to be the element at nums. So we can just replace both of those with value. So you can see that it's a lot fewer characters to do this loop. Let's go ahead and run it. And there it ran. Okay. Now, is there a downside, ever a downside to using the for each loop? Yes, there is. So let me back up all the way out of here. Okay. So if we go back to the way we were before using this index, and let's just make sure we run again. Yes. So another possibility is instead of doing this max value, what I could have done is I could actually look at the index. So I could say int max index is equal to 0. Okay, so that saves me the trouble of having to index into there. And then here, instead of doing this, let me go and comment this line out. Comment this line out. I could replace that with if nums index greater, instead of max value, I can now do nums of max index actually it's already got close brace. So if it's greater, then we're going to, oh no, I do need a close brace. Then what we're going to do is max index equals index. Okay, so instead of keeping track of the value, I'm going to get the index. And then instead of returning the max value here, I can return max index, not the index, but the value by indexing into nums. Okay, let's try running that. Okay, and that did work. But that's not what I was trying to show you. What I was trying to show you is what happens if we want to replace this then with that for each loop. Remember the for each loop? Int value in nums. Okay. The problem is that if we do this here, we never get this index value here. Okay. So because the index value is never found, we can't do it this way. It just won't work. We can't use the index. We have to go back to this way here. And so it's not always as simple as this case here where you could just do one or the other. Sometimes you really do need the index. You need to know where it was in the array that you found the element. So in that case, you can't use the for each loop, all right? So I'm going to go ahead and I'm going to try to back out all of this and just get us back to the for each loop. Looks like I may have backed out too far. But anyways, so if you want to use for each, that's great. It'll shorten your code, but the problem is that if you use for each, you will not be able to get the index, okay? So if you need the index, you have to do it this way. This way is always guaranteed to work, okay? And so from that extent, many students really are best off just using this and not using for each. When you get to 143, there's a lot more times when you really want to do the for each loop. But in 142, a lot of the times, it's just simpler just go ahead and write out the long way. All right, so what did we learn in this? So this was a refresh from section 4.2 on min-max algorithms, but applied to arrays here, okay? So we talked about how you can use the for each loop on arrays and shorten your code. And we talked about how you can apply the min-max algorithm. You have to get the first element of the array, and then you're checking each time to see what the max or the minimum is. But it's very similar. Mainly, we're just learning about how to loop through arrays. So if you found this useful, please like and subscribe. I've got a complete curriculum about building Java programs, and I do a lot of these practice it programs.